Assalamualaikum and good morning. So today chapter is about mechanical separation. You may refer chapter 30 in the books. Chapter 30, page 994. So the first method is screening. So based on the name, mechanical separation. So it's separating the material. This is for solid. Mechanically using mesh and vibration. So for screening, since it's using mesh, so it's separating the material based on size. So screening is a method of separating particles according to size alone. In industrial screening, the solid are dropped on or thrown against a screening surface. The undersize or fine pass through the screen opening. Oversized or tail is not. So need to understand there are two terms. The undersigned or fine will pass through the screen. So passing through the screen meaning it doesn't meet the criteria of the solid that we want to obtain. Oversized hotel do not. So oversized hotel will stay on the mesh. The coarse particle drop easily through large opening in a stationary surface, but with fine particle, the screen surface must be agitated in some way, such as by shaking, gyrating, or vibrating it mechanically or electrically. So this is a stationary screen and grizzlies. So a grizzly is a grid of parallel metal bar set in an inclined stationary frame. The slope and the path of the metal are usually parallel to the length of the bar. Very close fits as primary crusher fall on the upper end of the grid. Then we have a comparison of ideal and actual screens. So the objective of the screen is to accept a fit containing a mixture of particles of various sizes and separate it into two fractions and underflow that is passed through the screen and overflow that is ejected by the screen. An ideal screen would shortly separate the fit mixture in such a way that the smallest particle in the overflow would be just larger than the largest particle in the um, underflow. So such an ideal separation uh, define a cut diameter DPC that mark the point of separation between the fraction. Usually DPC is chosen to be equal to the mesh opening of the screen. Metal balance over screen. A simple metal balance can be written over a screen, which are useful in calculating the ratio of fit surface size and underflow from the screen analysis of the tree stream and knowledge of the desired cut diameter. So let F, D, and B be the mass flow rate of the fit overflow and underflow. So XF, XD, XB be the mass fraction of material A in this tree stream. The mass fraction of material B in the fit overflow and underflow are 1 minus XF, 1 minus XD, and 1 minus XB. So XF, F refer to fit. D is overflow, B is the underflow. So need to be able to define each of the term here. What is overflow, especially overflow and underflow. Okay. Since the total material fed to the screen must leave it as underflow or as overflow. Mm, so the word underflow is the material that passed through the screen. Overflow is the one that is rejected by the screen. For this equation, we can use equation 999. So F equal to D plus B. D is overflow, B is underflow. So the metal A in the fit must also live in these two streams, and FXF equal to DXD plus BXB. Elimination of P from equation 30.1 and 30.2 give D over FXF minus xb. This is equation 30.3. Elimination of D give 30.4. So F is still the same. It's F is fit. So fit is equal to D plus B, or overflow plus underflow. So screen effectiveness, the effectiveness of a screen, often called the screen efficiency, is a measure of the success of a screen in closely separating materials A and B. If the screen functioned perfectly, all of material A would be in the overflow, and all of material B would be in the underflow. The one is ideal or perfectly function, but some will stay also. Material A might stay in over the screen, and some B might, pass through the screen. A common measure of screen effectiveness is the ratio of oversized material A that is actually in the overflow to the amount of A entering with the fit. So this quantity are DXF and FXF. So XF refer to the mass fraction of fit. We have equation 30.5, which is the screen effectiveness. This is based on the oversize. Similarly, an effectiveness EB based on the undersized material is given by 30.6. So 30.5, this is for the overflow, yeah, or oversized material. 30.6 is based on the undersized material. Okay. So a combined overall effectiveness can be defined as the product of the two individual ratios, and if this product is denoted by E. So equal to EA, EB. So that equation is, oh, there's no number. So, okay, the one is combination of EA and EB, substituting D over F and B over F from equation 30.3 and 30.4 in this equation. So we have 30.7. So E, if screen effectiveness equal to this. So this is the complete equation. But you need to know XF, what is XF, XB, XT. Okay. So example 30.1, a quartz mixture having the screen analysis shown in table 30.1 is screened through a standard mesh screen. Calculate the phase ratio of the overflow and underflow to fit and the overall effectiveness of the screen. So table 30.1 screen analysis, for example, 30.1. All right. So we have mesh for until pen. So this is the DP. DP. It's a cut off. Cut off size for the map. Oh, kataan sesuai. Cut diameter. Yes. So DP refer to cut diameter. So cut diameter refer to defined as the point of separation between the fraction. So the higher the mesh, the smaller the DP or cut diameter. So cumulative fraction smaller than DP. So for this one, none at mesh 4, none. For mesh 6, it is smaller. It's tighter now. So we have some fraction. In the feet. So at mesh 65, TP is smaller, 0.208 millimeter. So most of the quartz mixture is in the feet. Yes. And it is under the floor. So when you in the pen, if we in the pen, so we have feet is use fraction smaller than DP. 1 for the feet, and the floor is 1. So cumulative analysis of feet, flow, and product plotted figure 30.3. The cut point diameter is the mesh screen size of the screen. Which from table 30.1 is 1.651. So from table 30.1 for this screen, so for mesh 10, this is based on the patient. Mesh 10, when okay. So for mesh 10, so cumulative fraction smaller than the DP. So if you refer to table 30.1, so fraction smaller than dp in the feet is around 0.47 only. So from the 0.47, 0.85 is the overflow. Only 0.195 is the underflow. So overflow refer to the oversize, underflow refer to the undersize. So for this XF is 0.47, XT 0.85, this XP is 0.195. So from equation 30.3, D over F. So we get 3 over F equal to 0.42. The ratio of underflow to feed is 1 minus D over F. So the overall effectiveness from equation 30.7 is 0.669. So this is the exercise based on the standard 28 image screen. Yeah, we follow the same method to calculate E. Okay. Filtration based on page 1002. So filtration is the removal of solid particle from a fluid by passing the fluid through a filtering medium or septum on which the solids are deposited. So filters are divided into 3 main groups: cake filters, purifying filters, and possible filters. So the cake filter refer to 30.4a. It's page 1003. So separate relatively large amount of solid as a cake of crystal or sludge, as illustrated in figure 30.4. 30.4a. So clarifying filters remove small amount of solid to produce a clean gas or a sparkling clear liquid such as beverages. The solid particles trapped inside the filter medium, as shown in figure 20.4b, or on its external surfaces. Okay, this is a cake filter. Clarifying filter, this is the cross filter. So for the clarifying filter, it's like a cake filter, but the difference is the cake filter. The cake is formed on the surface of the medium. Here, the pollutant is trapped inside the. So this is the pore. Yeah. So in a cross flow filter, this is cross flow filter. So what happened here? The water pass parallelly to the membrane. Yeah. So here the concentration is lower, since we can filter the water or the targeted particle or material. So the rest that after the filtration happen, you see this is what we call the retentate. It should be got higher concentration compared to the feed or suspension in this case. A thin layer of solid, this is the thin layer of solid, may form on the surface of the medium refer to the membrane, but the high liquid velocity keeps the layer from building up. Because the velocity, the flow rate is high. But although it's high, the pressure difference must be there. Yeah. Meaning here is a high pressure, this is a low pressure. So water can, or the fluid can pass through the membrane. Cake filter. At the start of the filtration in the cake filter, some solid particle enter the pore of the medium and are mobilized. So since it's immobilized like this, so the cake itself is turned into a secondary filter along with the medium. So when the medium here is we can say this is the filter or the membrane. Filter not necessarily a membrane. It can be a ceramic filter, can as well. So the cake that build up on top of the surface will become a secondary filter, which can filter the incoming pollutant. But there's the disadvantage. So since the cake filter, yes, it's good because it can it can assist to remove the pollutant, but the flux, what can I say? The rate of the fluid passing through two type of filter will be slower. So meaning you can collect product slower than without the cake filter or without the secondary filter. After this brief initial period, the cake of solid does the filtration, yes, and not the septum. A visible cake of appreciable thickness will up on the surface and must be periodically removed. Yes, correct. So after some time, the concentration of the cake is too high, meaning only some fluid can pass through the filter. So when the time comes, they need to do a cleaning either in situ. Normally it's in situ cleaning. Depend if you need chemical cleaning, then you need to take it out. Yes. But normally for membrane filters, we can last 3 to 5 years. Yeah. Then filter press. A filter press contains a set of plates. This is the plate. To provide a series of chambers or compartments in which solid may collect. The plate are covered with filter medium such as canvas or sometimes using cloth like a fabric. Slurry is emitted to each compartment under pressure. Liquor pass through the canvas and out or discharge pipe, leaving a wet cake of solid behind. Okay. So this is a filter press. If you refer to the book, there are many type of filter. So maybe 5, 6 pages just to explain various type of filter. Yeah. You can refer to the books, page 1004 until 1016. All of it is discussing various type of filter equipment. So principle of cake filtration. So this is the first cake filter. In cake filtration, the liquid passes through two resistors, which is the cake and the medium. So the overall pressure drop at any time is the sum of the pressure drop over medium and cake. So if PA is the inlet pressure, PB the outlet pressure, and the P prime the pressure at the boundary between cake and the medium. That one you can refer to. Oh, okay. That one you can refer to figure 30.14. To understand the equation 30.8. Okay, so it says here delta P is the overall pressure drop. which is equal to PA minus PB. So PA is the incoming. So incoming, then it will first reach the cake first. So after the cake, then the filter, the medium itself. Or in this book, they call it a septum. After the septum, then the filtrate, which is the clean water normally. So PE is equal to PA minus P prime, you see. Right? So the P prime here refer to because it starts with cake. So PA is when the pressure hit the cake first. Then the pressure will drop within the cake, theoretically. Then when it start to reach the surface of the medium, so that is what we call the P prime. So from the P prime, it will drop again the pressure when it reach at the end of the filter to the filtrate side. That one we call a PB. So there's a pressure gradient, which is true. In order for the filtration to operate, there will be a pressure difference, delta P. Otherwise, it cannot be done. So that one is equal to delta PC plus delta PM. So pressure drop over the cake and pressure drop over the medium is different. It should be different because cake normally is quite thick, depend on how long the cake boil up, and the media is the thickness is the same. Should be the same. This is some completion, but should be the same. Okay. Thank you. So next class is still drying. Actually.